Okay, today we're going to look at solving inequalities, particularly solving linear inequalities. And if you remember from last year, the year before, inequalities can have one of four symbols. We can have a less than or greater than sign, and we can also have a less than or equal to, that's what that line under there means, or a greater than or equal to sign. And unlike an equation, an inequality can have more than one solution. It can have an infinite number of solutions. So when we graph that solution, if the inequality has a less than or greater than sign, we use an open circle, and that means we're not going to include the number. So let's take a look at t is greater than 2. If we fill in our number line right here, it's anything that is greater than 2. So we're not going to include 2, but we need to know where to start from. So that's why we use an open circle. And then we shade in all the numbers that are greater than 2. And that's 3, 4, 5, 6, 7, and so on. And we can go on forever. If the inequality symbol is less than or equal to, that's where we use a solid circle, because that includes the number. This less than or equal to means we're going to include 4.25. So let's go ahead and number our number line, and I'm going to do a little skipping around here so we can be a little more accurate. This would be 4, 3 would go right here, and 2 would go right there. So that means we can have 2.5 here, 3.5 right here, and 4.5 right here. So when we go to graph 4.25, we're including it, so there's a solid circle, and then we shade everything to the left. And that arrow goes on the end because we are including everything smaller than 4.25 and including 4.25, so we have to make sure it keeps on going and going and going. This one over here I forgot to do, so if you want to pause it and check it, open circle at -3 because it's less than. We want all the numbers less than and up to -3, and again, make sure you include your arrow on the end. Hopefully it's nicer than mine. Okay, so there's one thing when we're solving linear inequalities, we solve them just like an equation, but there's only one little, I guess, hiccup in there. The direction of an inequality can change if we multiply or divide both sides by a negative number. And what that means is after we distribute and after we undo addition and subtraction and we're trying to isolate our variable, we're going to have one more step. And when we undo multiplication or division, if the number we're multiplying or dividing by is negative, that is going to, I'm going to cross this part out, I don't like it. It is going to flip the inequality symbol. Okay, so just like when we solve equations, first step is always to distribute if you need to. Simplify using the inverse of addition or subtraction. And this is the step right here. This step 3 right there. That's going to determine whether or not we have to flip the inequality, because if that number is negative, it will flip the inequality. So if we're undoing the inverse of multiplication, which is division, or the inverse of division, which is multiplication, that's going to flip our inequality symbol around. So let me show you what I mean in this first example. And again, we're solving these just like we solve an equation. What we do to the left side, we have to do to the right side. So I'm going to add 2. That's not going to do anything to the inequality symbol. It's going to keep it the same, so we get -4x, is less than 10. So this negative right here we have to divide by to isolate the variable. So we divide by -4, divide by -4. They cancel, and we get x is greater than. It flips the inequality symbol around, and we're going to simplify that to -5/2. So if we were to graph that, it would be an open circle on -5/2, and we would graph everything bigger than that. Okay, next example. There's my river. I want to undo this positive number by subtracting it. They cancel. Left side, -19, greater than or equal to -3h. This is the number I need to get rid of, and it's negative, and I undo this multiplication by division. So when I divide by that -3 on both sides, I get 19/3, and that inequality symbol flips around. So I get h, or 19/3 is less than or equal to h, or h is greater than or equal to 19/3. Last one. We have to distribute. 2j minus 8 is greater than -6. Add 8. And j is greater than 1. Okay, so that should be a review from last year. This year, we are going to take a look at compound inequalities. And compound inequalities are inequalities where there's more than one, usually just two, and they're connected by an and or an or. So, for example, an example that would be car seats. For a baby to ride or a child to get out of a baby car seat, they have to be 20 pounds and at least 1 year old. That would be a compound inequality. And again, there's two types. We can have an and inequality. And how do we know it's an and? It has the word and in it. And inequalities are true if both of the inequalities are true. The graph of an and compound inequality is the intersection of the graphs. And to find the solution, we look to see where the graphs intersect or where they overlap. And that will be solution to both of the equations. So this inequality right here is an and. Well, is the word and missing? It is, but we don't see the word or, so we know that it's an and. So 4 is less than n plus 6 is less than 9 can also be stated as n plus 6 is greater than 4, which is this inequality right here. And we can also say it as n plus 6 is less than 9, which is this inequality over here. And there's two ways you can solve these. You can solve these separated, and this would be n is greater than -2 by subtracting 6. Subtract the 6 from this side, and we get n is less than 3. And in both those, we subtracted 6. Well, we can treat this as a double equation. I want to get, or double inequality, I want to get the n by itself, so I would minus 6. Subtract 6 from each side. This would give me -2 is less than n, which is less than 3, which is what we ended up with over here. So when we graph that, when we graph n is greater than -2, which is just this flipped around, open circle at -2, and we want to shade in everything that is bigger than -2. When we're graphing n is less than 3, open circle at +3, and then we're shading everything to the left of +3. So our solution set is whatever is in between these two dashed lines. It will work in the equation n plus 6 is greater than 4 and in the equation n plus 6 is less than 9. The other type of compound inequality is an OR inequality. And how do you know if it's an OR? It'll say it. The word OR has to be in there. It has to contain the word OR. And OR inequalities are true if one or more of the inequalities is true. The graph is the union of the graphs. So for an OR inequality, you're just solving two separate inequalities and graphing them on the same coordinate plane. So when we solve this one, we're going to add 5 to each side, and we get 2k is greater than 12. Divide each side by 2, and we get k is greater than 6. And it's an open circle. So let me extend my number line. Open circle on 6, and we're shading everything to the right of 6. For 3k minus 1 is less than or greater than 8. Add 1 to each side. We get negative 3k is greater than 9. We're dividing by a negative 3, so that is going to flip my inequality symbol around. So again, it's greater than, so open circle on negative 3, and we're going to shade everything, wrong direction, everything that is less, than negative 3. So in an OR inequality, we only need a solution that works in either 2k minus 5 is greater than 7 or in negative 3k minus 1 is greater than 8, and we can get our solutions from this side or from this side. Okay, now it's your turn to answer multiple choice question number 1. Which line is the mistake in the solving the inequality below? Be careful because there may not be an error. And then number 2, solve for k. And be careful with number 2. It might look like a compound inequality to you, but it's not. It just has one inequality symbol. So again, you can treat that as an equal sign. Be sure to enter your answers in the Google form.